let's add some ocean displacement to our mesh here. And what I have here is a simple grid, which is roughly the size of my mesh geometry. And what I want to do is I want to try and test things on a simple grid rather than that detailed looking mesh. And then I'll copy over the ocean spectrum and ocean evaluate nodes to my mesh later. So to convert our grid into an ocean here, we need two nodes, starting with an ocean evaluate and an ocean spectrum. Now the ocean spectrum is where all the magic happens. This is where you change the settings to get the desired looking ocean for your scene. So I'm going to connect the grid to the first input, which is geometry to deform, and the second input of the evaluate is asking for an ocean spectrum. So I'll do that there, and then I'll visualize that. And we don't really see much of a difference. Yes, we do see some displacements here, and if I play this, you would see that it kind of moves up and down a little. But if I add a little bit more detail to my grid in terms of my polygons, you can see that in an instant we see a lot more details in our ocean. Now obviously we have to match the scale of our scene, and we have to make sure that the scale of the splash matches the scale of my spectrum. So what I'm going to do is I'm going to change a couple of settings in my ocean spectrum here. And I'm going to say increase the grid size to 100, so I've got a little bigger grid to work with, so it would get rid of repetitive patterns in your spectrum. And then obviously I need more resolution, because now you can see that there is some blockiness, or you can see that it's not as smooth as I would like it to be. So what I'll do is I would change the resolution exponent to 9 from 7, and you'll see it adds a lot more tiny details that weren't there before. So let's put that down back to 7. You can see we don't really see many details here, but if I put that to 9, you can see a lot more. If I put that to 11 or 10 rather, you would start seeing a lot more tiny details. But for this shot, I think 9 is a good number. Now be careful changing this setting, because it can be very heavy on your system. Okay, so now if I play this, you will see that our ocean is moving here. It's quite nice. It's a lot better than what we had before. Now let's take a look at some of the settings in the wind tab. Now you will see, if I zoom this out and if I play this, you would see there is some sort of directionality to my spectrum, and I don't really want that. So what I'll do is I'll put the directional bias and the directional movement both down to 0. And what that would do, it would make the ocean move, but it wouldn't really make it go in a direction. So the directional bias and directional movement are the settings that are helpful when you want to change the direction of your spectrum, or when you don't want to have a direction. Okay, so I feel like this ocean is also a little bit too strong. What I can do, I can decrease the speed to 4, and it goes a little bit more flat. Okay, and in the amplitude, I can put the scale back down to 2 as well, so you will see it becomes a lot more calmer. And I can put the reference wind to 15 to, you know, fake the scale, that large scale, just a bit more. And if I play this now, you would see it moves. It barely moves, but it moves, and that's what we want. Now what we want is we want to keep the exact same look what we have here, but we want to decrease the time scale to make it move even slower. But don't change any speed or any grid size or any scale of any sorts. So what we can do, we can put the time scale down to 0.5. This will keep all the settings that we put in here, but it will time scale our animation to half, or whatever number you put in here. So if I play now, you would see that our ocean is moving, but it's barely moving, and that's what we want. We want the ocean to not move much, but it's just there because, you know, before our spaceship crashes into our tank, it's a calmer looking ocean. There is not much going on. So now the question arises, I'm going to connect this to my mesh here, and this might take some time to compute. Okay, so now I have connected this to my mesh here. Now the problem is, if I go to, let's say, frame 94, this ocean spectrum is also being applied to my splashy areas, and I don't really want that. I don't want the splash or my areas where the velocity is to get my ocean spectrum. So if I, let's say, if I visualize my mesh back again without the ocean spectrum, you would see that this would go back to its original state. Oh dear, there you go. So this would go back to its original state. And if I put this to ocean evaluate, it would add these details or these ocean displacements to my mesh here. So how can I fix that? Well, the solution again is very simple, and because Houdini is set up in such a procedural way, we can have full control where our ocean spectrum goes and where our ocean spectrum doesn't go. So what I'm going to do, I'm going to drop down a simple point warp, and the first input I'm going to take from my mesh here, and the second input I'm going to take from my ocean evaluate. Okay, I should turn this to manual so it doesn't compute every time I do something. Okay, and inside, what I'm going to do, because our mesh has a V attribute, we're going to take that V and mask our ocean spectrum out of it. And to do that, what we're going to do, we're going to mix the position of the ocean spectrum, which is this, and our mesh, which is this. So we're going to take these two positions and have a mix between them two, and we'll bias that with the velocity of our mesh. So let's drop down a VOP, length VOP here, and calculate the length of my velocity. Okay, let's drop down a mix node, and the position of my first input, which is my original mesh. And what I want to do is I want to drop down an import point attribute, and second input, connect that to file. So what that's going to do, this is going to import the position from my second input, which is our ocean mesh. And I'm going to put that to input 2 in mix. Okay, and then the length of my velocity, I'll bias that mix with. And to control it, I'll drop down a fit range. Okay, and then the output of my mix goes into the new position, and if I want to visualize and control how and where my ocean spectrum should go, I'm going to connect a ramp parameter, not that one, but a ramp parameter to the output of my fit, and the output of my ramp can go to CD, which is the color attribute. Alright, so let's visualize this and see how this looks. So now you can see that we have this ramp and our ocean spectrum is masked. But what is happening right now is that anything that is our splash is taking our ocean spectrum, and this is not taking our ocean spectrum. So we want the opposite. So there are a couple of ways to do this. Either what you can do is you can promote the parameter sourcemin, sourcemax, and I'll do that right now. It might take a while because obviously the scene is heavy, and every time you do something, Houdini computes. Right, and then what we can do, we can switch these numbers. So from 0 to 1, let's say from 1 to 0. And that would give us the result that we want. So it would give us ocean spectrum on these areas, and it would take away ocean spectrum from our splash. And to fix this a bit further, what we can do is we can change these values. We can make this tighter. So I'm going to put, okay, let's go manual and put this to 0.1, and then put the minimum value to 2.75. Now what this would do, this would give us a lot tighter looking mask for our ocean spectrum. There you go. So it's going to have these ocean displacements here, but not there, and you can see there is a bit of a gray area here. So it's going to have these ocean details here, but a tiny bit, so not much. So this is a good example of how we can blend the positions of two different datas. So you can obviously change the colors as well if you want. So you can do a blue here, and you will be able to see this a lot better. So obviously you can say that we don't really have any ocean spectrum on our splash here, but we do have the ocean spectrum outside. Okay, so just to compare, if I visualize this, you would see Houdini would add details to this area right here, and so there you go. We are starting to see some ocean spectrum here, and we don't want that, and that's what our mix is doing. It's taking away the ocean spectrum from our splash here, which is calculated based on the length of the velocity. Okay, now I can put an attribute delete node down and delete the CD attribute, which is the colors, to get rid of our ramp here. And after that, I can put down a normal sub to recompute the normals of my mesh. And then obviously I will put a file cache node so I can copy paste this and rename this. Okay, so copy paste that. Let's go full screen. And then I'll name this Spectrum Mesh. Okay, and null out mesh. There you go. So now we have a fully fleshed ocean spectrumed mesh for our shot here. And then again, obviously, if you go to auto update, it's going to take its time to compute. And you can see that we don't really have any of the ocean spectrum on our splash, but we do have the ocean spectrum outside our splash. And we have a flipbook here that I did earlier with fully fleshed ocean spectrum and the splash itself. So you can see that as soon as our spaceship touches the splash, the ocean spectrum starts to diminish from here, and that's what we want. That's the kind of detail that we're looking for. And this concludes this tutorial, and I hope that you learned a lot from this, and I can't wait to see what kind of simulations you guys come up with. You can reach me out via email or on my CG Circuit account if you have any problems. And I will see you guys in the next tutorial, where we will talk about on how we can take all these elements that we created in this tutorial, make custom shaders for them, and then set up our Manta renders and ultimately comp them in Nuke.